This video is to help explain end behavior, and this is going to be a longer explanation. So if you just need the shortcut version, I do have a shorter explanation in another video that you can go look on my YouTube page. All right, so let's just take it really slow and talk about just a very basic example. Let's say we have f of x equals x squared. Now, if you've worked through some problems like this before, you know that is a quadratic function that makes a parabola graph. So we know that it's going to be a U shape. If you didn't know that, then you could certainly plug in numbers. And I kind of want to talk about that in the context of end behavior. So end behavior is what is happening at the ends of the graph. So if I go all the way and make x really, really big, what are my y values doing? Are they going to increase and become big, big, big positive direction, or will it become a really small or really large negative number? And then what is happening on the left-hand side? As my x values decrease, as they get further and further in the negative direction, what is happening with my y value or my function value? Is it increasing, or is it going up to positive infinity, or is it going down to negative infinity? So our end behavior is going to either be going up or down, up to positive infinity or down to negative infinity. And each side can be either the same or different. And that's going to be one of the things we talk about today. So if we're looking at our very basic x squared, let's say we don't really care about what happens here in the middle. And I'll explain why here in a minute. But again, this is end behavior, so I'm just worried about the ends for right now. So I'm going to draw my xy axis, but again, I don't care about the middle part right now. If I wanted to figure out what was happening with this function at the ends of the graph in each direction, I might want to try plugging in a big number. So let's say I wanted to try plugging in, I don't know, let's say 20. Let's say 20. So I would have 20 squared. I would have 20 squared. That's going to be 400. So we can see, okay, obviously this is, I'm not going to be able to graph this, right? But if I go all the way out to 20 this direction, then I know that I'm going to get a point that's way, 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 way up here. So I know that as this graph goes on, you know, if I plug in 1 squared would just give me 1. So I'd be here. Okay, and this is not to scale. But you can tell that over time, this is going to start going up, 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 like this. Okay? And then let's see what happens if I plug in a really big negative number. So negative 20, I would have negative 20 squared. And again, being really careful here with these negative numbers. So this is why this works, because whatever I plug in, I have to put in parentheses. So this is going to end up being negative 20 times negative 20, which is 400. Okay, now you don't have to pick 20. You could pick 50. You could pick something really big. You don't want to pick something smaller because you're not really sure what happens here in the middle. But if you pick a bigger number, let's see what happens. You end up getting 400 again. So even though I'm going in the negative x direction, I'm still up here at 400. So my graph is still going up that direction. So what we know is that this polynomial that I'm given here is positive. And we also know that the degree is 2. And that number 2 is even. So this is an even degree polynomial. One thing that you can go ahead and put in your memory is that if it is an even degree, the end behavior is same on both sides. Okay, so whatever happens on the right-hand side, as you can see here, this went up like this. Guess what happened on the left-hand side? It also went up. And that will be the case every time for an even degree polynomial, if it's positive. Okay, so that's if it's positive. Let's look at a very basic case. So that was one case. Let's look at another very basic case if it's negative. So let's again go back to our x squared, but let's make it negative. Let's say negative x squared. And let's see how that changes the graph. Now, some of you probably already know what this looks like. But in case you don't, let's do the same process. So if I was to pick a number, let's say 20, and again, you can pick 50, 100, you can pick whatever, just pick a fairly decent big number there. If I was to pick 20, what happens? So we have to be careful when we plug this in because this is negative 20 squared. The negative does not go on the inside here. So I end up with negative 400. So even though I'm way out here at 20, I'm going to be down here in the negative direction. This is going to tell me that my graph is going down here. And we can already say, based off of what I said up here, that because this is an even power, that my other side should do the same thing. But you could always try a number. So if I wanted to do the left side here, I would plug in negative 20. I would have negative and then a negative 20 squared. So this would be negative and then negative 20 times negative 20, which is positive 400, but the negative still is there right here. Okay, so even at negative 20, I'm down at negative 400 and I'm going down. So this, you can see already that our even degree is doing the same thing. So we have a degree of 2, that number is even, and our even degree goes in the same direction for the end behavior. So this goes down and this goes down. Why did it go down? That is because our sign was negative. So up here, we had a positive sign, it went up. Down here, we have a negative sign, both went down. And again, they both go down if the degree is even. Okay? All right. I want to pause real quick because there's another part of end behavior that we haven't talked about, and that is writing it in a more formal way. So sometimes we write end behavior using more mathematical language. Instead of saying up and down, we use infinities. So we can write a statement that says, as x approaches infinity, f of x approaches what? So what this is saying is, as x gets bigger and bigger, so 20, I plug in 20, I plug in 50, I plug in 100, what do those values of the function or the y values do? Do those get bigger or do they get smaller? As in, do they go to the positive direction or negative direction for our y values? And we can see when we plugged in a positive x value here that was big, we ended up getting a positive y value or function value out. And we can also see on the graph that it's going up. So what we're saying is that this is going to continue to increase and go towards infinity. So in that blank, as x is going in the positive direction, the function is also going in the positive direction, the value. We can say as x approaches negative infinity, the function approaches what? So this negative infinity means going in the negative x values direction. So as I go in the negative x values direction, what is my function doing? What are my y values doing? And we can see that my y values are increasing and going up to positive infinity. So in this blank, I would also put positive infinity. Again, if this is even and positive, both of these are going up, and both of these will be positive infinity. Let's write that same type of statement for this other one that we were working on. Okay, so as x approaches infinity, f of x approaches what? Okay, so as x approaches infinity, that means as x gets bigger, what are my y values doing? What are my function values doing? And you can see that my function is going down, so my y values are going down. So in this blank, what I'm saying is that this is going to negative infinity. And we can see when we plugged in a positive x value that was big, we got a negative y value out, or a negative function value out. Continuing with the statement, as x approaches negative infinity, the function approaches what? Okay, so what I'm saying here is if I'm looking on the left side, as x approaches negative infinity, that's going to the left, what is my function doing? My function is going down here. So this is going to continue down in the negative infinity direction. So our first two examples were really just talking about even functions. So we talked about a positive even, both sides turn up, a negative even, both sides turn down. So I want to just real quick do a couple examples with that. So let's say we had f of x equals negative x to the 6th plus x to the 5th minus 3. So first off, you're looking for the leading term. The leading term, if it is in standard form, and it is in this case, the leading term is going to be the term with the variable with the highest exponent. So I have a negative x to the 6th. So let's talk about our leading term. If we have negative x to the 6th, we have an even number here and a negative number out front. So negative means it's turning down, and both sides are doing the same thing, which means I'm going down and down. Okay? I'm not going to do the statements on that, but I just wanted to show you that example. Let's do one more. So let's say we have f of x equals x times x plus 3 times x minus 2 squared. So this one's in factored form, a little more difficult to find the leading term, but our leading term here is, this is x to the 1st. This would be x plus 3 to the 1st, and then I have x minus 2 squared. So if we're talking about degree, remember multiplicities add up to degree. So we have 1 plus 1 plus 2, and this would give me an x to the 4th. And I have a positive number out front, which means that our leading term is just x to the 4th. Again, you can kind of look at this as x to the 1st, x to the 1st, x squared, and if I have all of those, I add exponents. So looking at this one, I have a positive and an even. So that means that even means it's going the same direction, and positive means both of those are going in the positive direction. So that was two quick examples with even multiplicities. Let's take a minute and do odd multiplicities. Okay, so if we have odd multiplicities, let's say we have just a very basic odd function. Not multiplicities, I'm sorry. Degree, odd degree. Odd degree. So this is going to be x to the 3rd. Let's look at the characteristics of this function. We have a positive, and now this degree is 3. So this degree is odd. That number is odd. So let's try doing the same thing as what we've done before and plugging in, a big number, which I'm going to still use 20. I would say in most cases 20 would work. There might be a few random crazy cases that it doesn't, but most of them should. Okay, so if I plug in 20 and I cube it, I'm going to get something really big. What am I going to get here? Let's see. I'm going to get 8,000. Woo! So if I was to graph that, I'd be somewhere out here in La La Land. But long story short, I know that my graph at the end there is going to continue to go way, 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 way up. And if I was to do negative 20, we have to be careful here. Because if I do negative 20 squared, negative 20 cubed, if I do negative 20 cubed, this is negative 20 times negative 20 times negative 20. So I actually end up getting a negative number as a result, and my function value is negative there. So if I go here, way out here at negative 20, wherever that is, I'm going way down here, negative 8,000. Okay, so what that is telling me, without having to actually graph that, what that is telling me is that that graph is going down on the left-hand side. Okay, so what were my characteristics? It was positive, odd. So I'll go ahead and tell you the trick on the odd degree is that they go in different directions. Or opposite. Okay, so they're odd opposite. So we're going in opposite directions. So if my right side's going to the positive direction, my left side's going to the negative. And the trick on this also is if this is positive out front, that is telling the right side that it's going positive. And that actually works with the other two things that we did too. So let me go back and show you real quick. If this was positive, my right side went positive because when I plug it in, it's a positive number. If it's negative, my right side went negative because when I plug it in, it's a negative number. Negative here, right side negative. Positive here, right side positive. Okay, so there's a pattern resulting here, and that is that the sign is basically going to tell the right side what to do. Let's go ahead and write our statement for this one. So as x approaches infinity, f of x approaches what? So that means as our function gets bigger and bigger, what is our function value doing? Our y values are going up, so they're going to infinity. And as x approaches negative infinity, our function is going in which direction? So let's see, if I go further to the left side, my function is going down. My y values are going down, so I have to put negative infinity there. Okay, so we have one more case. What happens if I have f of x equals negative x cubed? So if I was to do this, let's see if we can figure this out. Oops. Let's see if we can figure this out without having to, whoops, sorry y'all. Pause. There we go. Let's see if we can figure this out without having to actually plug in numbers, okay? So if we think about what I've been saying, if the number or the sign in the front is negative, that automatically tells that right side, no matter what number I plug in that's positive, I'm getting a negative out. So that right side's going down. And then I also said that this degree right here, being that it is odd, it is going to do the opposite, or it's going to go in different directions. So that means that on the left side, I'm going up. Okay, so what I don't want you to have to do every time is plug in numbers, continue to plug in numbers. That takes time, and it's not wrong. It's just over time, I want you to start understanding the pattern of these things. Okay, if this is our end behavior, then let's write our statements. As x approaches infinity, the function f of x approaches what? So here we are going to the right-hand side, and our function values are going down. So this would go to negative infinity. And then as x approaches negative infinity, our function values are doing what? Okay, so as we're going to the left-hand side, in this case, our function values are going up. Our y values are going up. So we're going to a positive infinity. So let's do a couple examples, and that will be it for this video. So let's just do a couple with the odd. Let's say we have x squared minus 3x to the 5th plus 7. So one thing we have to remember with this is anytime you're given a function and it's in standard form, which means that we have these terms and it's not factored, that we have to write it in descending order first, or at least that's helpful. So our descending order is negative 3x to the 5th plus x squared plus 7. And our leading term here would be that negative 3x to the 5th. Now, I want to make it clear, this 3, that number right there, really is not doing much as far as in behavior is concerned. So we can kind of just ignore it, really, because the only thing we're concerned about is the sign and the degree. Our degree is 5. That number is odd. Our sign is negative. So if I was just sketching this in behavior, I would end up being negative on the right-hand side. That means it's going down. And odd means it's doing the opposite on the left-hand side. So these are going in different directions. Let's do one more. So let's say we have f of x equals x plus 2 squared, x plus 3, and x minus 5 squared. So if we're looking for the leading term here, our number in front, or our leading coefficient, would just be 1. But we also have x squared. We have, remember, this is x to the first, and then we have x squared. So this becomes x to the 5th. This is a positive number, and it is odd. So if I wanted to sketch my in behavior, the positive tells me I'm going in the positive direction when my x's increase. So as my x's get more, go further in the positive direction, my y values are also doing positive direction. But if it's odd, I'm doing different directions with the in behavior. I'm doing the opposite. So that means on the left-hand side, it's going down. All right, if you've hung in here this long, I really appreciate this. There's lots of different things that can happen with the in behavior, but it all comes down to 4 basic concepts. It's either positive even, positive odd, negative odd. So if it's positive even, you're looking at both up. If it's negative even, you're looking at both down. If it's positive odd, you're looking at right side up, left side down, and negative odd is the opposite. Okay? So if you can remember that and know what I mean by the positive and the even and all of that, then that will help you get that in behavior down. All right, I hope this was helpful.